Mm-hmm. Alright, let's talk about metalloids. So, everything in the universe exists on a spectrum. So, as we move down to the left, so down and to the left, you become more metallic. As you move up and to the right, you become more non-metallic. But there exists, in the middle, a gray area, where it has metallic properties and non-metallic properties. Starting at boron, we're going to make a staircase. Yes. So, beside one thing, so there's going to be a few exceptions. Basically, you're going to look above the line and below the line and ask yourself, is it a metal? Is it a non-metal? If you don't know, metalloid. There's only one major one. So, above this, boron. You probably don't know what boron is, so metalloid. Would you say aluminum is a metal? This is the exception. So aluminum is going to not be in it. Silicon is most definitely a metalloid. Germanium is a metalloid. Arsenic is a metalloid. Antimony is a metalloid. This is where we get into issues, but going above here, this is a metalloid. Going below this line right here, I would technically classify this as a metal, and this one you can't really talk about anyway. So you can stop right here, and this would be good enough. So looking it up. So we can see from here that the ones shaded in green are extremely well recognized. Where'd they go? Why'd that move? So the ones shaded in green are commonly recognized as the metalloids. About 86 to 99% of all people, all countries, scientific communities recognize these ones as green as being metalloids. The one in blue are irregularly recognized, meaning about 40 to 46% of scientific communities will say that these two are metalloids. Polonium, the issue with this is anything after lead and bismuth is highly radioactive, are usually highly radioactive. After bismuth and lead, we get into unstable atoms. For the longest point, bismuth was considered purely stable. But in 2003, we discovered that it has a half-life that's longer than the age of the universe. So it's not stable. Lead is stable. So anything higher than lead is technically unstable. But polonium only has a half-life of about 6 or 8 hours. So very unstable. In fact, if you had 1 gram of polonium, it would be able to heat up quickly to about 500 degrees Celsius, just due to the radioactive decay. So highly, very hot. And this one is even shorter lived. It doesn't exist for very long, and so we don't have a good sample of that. The nucleus breaks apart. All the atoms are made in the heart of a star, or by decaying into them. Aluminum is rarely recognized, and carbon is rarely recognized too as being metalloid. I would most definitely count aluminum as a true metal. I would never say it's a metalloid. It doesn't have very many properties of non-metals. Some properties would be it's lightweight. It's very light for a metal. Does it have more properties as a metal or a metal? That's what I just said. Does it have more properties as a metal? I said it has almost all the properties of a metal. Were you listening? Let me repeat. Listen very carefully. I would classify aluminum as a true metal, meaning it has all the properties of a metal. However, it's due to its light weight. That's about the only non-metal property I see. Yes, it says 8 to 10% of people will classify it as a metalloid. I would not, because it's almost entirely metal properties. I can't. Yeah, and carbon, same thing. Carbon, I would classify as a non-metal. Carbon is diamond or your pencil lead. Pencil lead and diamond are both made out of pure carbon. Some metallic properties of carbon is the ability to conduct electricity. Your pencil lead can very easily conduct electricity. But that's about it that I can think of. I would not classify carbon as a metalloid. Selenium, same thing. It's not even on the ladder that I illustrated to make these. Aluminum is, but I wouldn't classify aluminum or carbon as a metalloid. Polonium, I would classify as a metal, but it is some of the time. The ones in green are the major ones: boron, silicon, germanium, arsenic, antimony, and tellurium. I'm never going to ask anything about polonium and acetine because that's nuclear chemistry. They're too radioactive to be useful in chemistry. So, make the staircase, look above and below it, and remove aluminum, and you can stop when you get to polonium. That's your metalloids. So a metalloid is simply something that has properties, metallic properties and non-metallic properties. And I really can't think of too many non-metallic properties of aluminum, so I don't classify it as non-metallic or metalloid or non-metallic. Um, Next, I want to go over solid, liquid, and gas. So let's talk about gas first. So gaseous elements. What are all the gaseous elements? First one would be all the noble gases, which is helium, neon, argon, krypton, xenon, radon. Or radon. So these are most definitely gases. And then the diatomic molecules, excluding bromine, and iodine. So, what are your diatomic elements? Your diatomic molecules is your hydrogen, and then it's going to be this L shape. Your nitrogen, your oxygen, your fluorine, your chlorine, your bromine, and your iodine. I said I said your gaseous elements include the diatomics, excluding bromine and iodine, and the notable gases. This is all your diatomics. So this one is gaseous. This one is gaseous. This one is gaseous. 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 This one is liquid, and this one is solid. So out of the diatomic, all of them are gas except for bromine and iodine. Does that make sense? And that's all the gaseous elements. What are the liquid elements? And when I say liquid, I mean at room temperature. So, what are your liquid elements? What's the most common liquid element on the periodic table? Gas. Mercury. Mercury is not only a liquid, it's also a metal. It's the only liquid metal. The other one is bromine. I just said it. Note gallium at room temperature, meaning about 68 degrees Fahrenheit, 20 degrees Celsius, is a solid but would melt in your hand. At 85 degrees Fahrenheit, I believe, something around that. So gallium is considered solid at room temperature, and we define room temperature to be like 68 degrees Fahrenheit and 20 degrees Celsius. Your solid elements is everything else. Around 85. You don't need to know the exact temperature. Only that if you were to touch gallium, your body heat is enough to melt it. Your solid elements is everything else. This includes iodine, and recall mercury is a liquid. Mercury and bromine is a liquid. This includes iodine, and recall mercury and bromine is a liquid. So if we look at a periodic table, we can see the position. All the yellow is solid. There's only two liquids, mercury, Hg, and bromine. And then the noble gases, and five of the, including hydrogen, with the diatomic elements. So most of everything is solid at room temperature. Alright, let's do the alien periodic table together. What was it? Yes. So it says these are the noble gases: Bombal, Womble, Jumpton, and Logon. And recall that the noble gases on the periodic table are the AA group. These are the noble gases. And remember that the noble gases, period 1 only has one valent cell. Period 2 has 2. Period 3 has 3 valent, or 3 shells. And period 4 has 4. Only the first shell gets full when it has 2 electrons. The rest require 8 to be full, the octet rule. And it says Bombal is a noble gas but does not have 8 valence electrons. The only possible spot it can go is in the first period, and it's the last column because it's a noble gas. There is one other thing I forgot to mention. The alkali metals does not include hydrogen. Sometimes it does, but for the most part, it is just 1A without hydrogen. Because hydrogen is not a metal. Therefore, it can't be an alkali metal. Yeah, first column excluding the first element. So, continuing reading, it says the outside energy level, meaning the outer energy level of Logon, is the second energy level. This means right here, it has to be period 2. And the fact that it is a noble gas tells you that it's period 2, column AA. So period 2, column AA is Logon. Of these noble gases, Womble has the greatest mass. As we add protons, neutrons, and electrons, it gains mass. So the very last one of the column or row is going to have the greatest mass, and that'll be Womble. Or Womble. Which only leaves Jumpton left, but we know it's a noble gas, so it has to fill this slot. So Jumpton has to fill the last spot in it. Which means we are completely done with this information. We've completed everything useful from that statement. The alkali metals are Zalt, Bayou, Chow, and Quacktzil. It says it's group 1 has alkali metals. All of these alkali metals, chow, the lowest mass, so it should be at the highest position, which it's CH for chow. And it says Quacksil is on the same period as Wumble. So same period as this, that would be Quacksil. So we're done with Quacksil and we're done with Chow. We know that Zalt, Bayou, and we know that Bayou and Zalt are in group 1, but we don't know exactly where we're at. So let's move on. The halogens, which is the group right next to the noble gases, group 7A, contains Apstrom, Valcania, and Krat. And it says Valcania is in the same period as Quacksil and Wumble. So that means that V should go in the same one. We're talking about 7A, so V should go there. We know that Angstrom and Krat should go in the same group, but we don't know which order they go in. So we'll figure that out later. And we have the metalloids. Oh no? That was earlier. No, the whole point of this is just to fill this out. I'm just making notes as I go on. That were my personal notes. So the metalloids are the ones by this black line, and they have stars by them. So it says these are the metalloids: Ernst, Hi-Ho, Terry Bloom, and Cissus. It says Cissus is the metalloid with the highest atomic mass. So this one has the highest atomic mass. And it says, so that information we used up, we don't need that anymore. It says Ernest is a metalloid with the lowest mass. That means Ernest has to go in the lowest mass spot. It says Hi-Ho and Tenebloom are in group 14. And it says Tenebloom has more protons than Hi-Ho. So group 14, there's 2 spots it could go in. And it says Tenebloom has higher number of proteins, which means Hi-Ho has to be up here with lower number of proteins. And both of them are in group 4. 4A. Or 14. It says the element called Yazer is also a metalloid by location, but has properties to suggest that it's a light metal. Yes, this is talking about aluminum, but we only have one more spot for the metalloid, so it'd have to go right here. And it's supposed to have a Z by it. The most metallic element on the planet is called Zalt. So where does the most metallic element go on the periodic table? You have to speak up. So where should the most metallic element go? What? I said, where should we put the most metallic element on the periodic table? So, how do you get more metallic? You go in what direction? You go left, and what other direction? Down. So the most metallic is down and to the left. So that increases your metallicity. So X should be right there. As you go down and to the left, you get more metallic. So the most metallic element should be the one on the bottom left of the periodic table. It says the most chemically active nonmetal on the planet is called apstrum. Where does the most chemically active nonmetal go? So it says nonmetal, so we know it's somewhere on the right side. But where is the most chemically active element? Hmm? You're confusing me. So non-metals are on the top right, metals are on the bottom left. Again, you become more metallic as you go bottom left, which means you become more non-metallic as you go to the top right. But the question is, where is the most chemically active or reactive element? Right next to SS? Why? Who strongly wants a electron? So strongly that it would rip it off of any other chemical it comes in contact with. We went over this on Friday. Nitrogen. You are not doing too well. So this is basically asking which one is the most electronegative. I went on a whole spill talking about how reactive this was, on how the super acids that compose it are able to react with every single thing, and the only possible way that you can make it contain it is by using Teflon, because Teflon even has a stronger fluorine. Fluorine is the most reactive element on the periodic table. It reacts with almost everything. So, the most chemically active nonmetal on the planet is angstrom. That's referring to fluorine. So remember, as you go up to the right, you get a higher electronegativity. This is basically the same thing as, I can't say it's reactivity precisely, but you could think of it, at least in terms of the nonmetals, as reactivity. It really, really strongly wants to grab an electron and will react with every single thing to do so. That's the reason why it doesn't exist as a single atom. Fluorine always comes with attached to something else. The lightest element on the planet is called PF. So what is this? Where does this go? Yes, what is the lightest element? What? Why would in the world would you say? What's the lightest element in the world? What is the lightest element in the world? So helium has an atomic mass of 4 because it's composed of a proton, another proton, a neutron, and a neutron. Hydrogen is the lightest element because it only contains a proton. Significantly lighter than every single element. Remember, the mass mostly comes from the nucleus. The heaviest element on the planet is Arado and is highly reactive. So where does Arado go? So where would Arado go? Do you not get what it means by atomic mass? Where does it go? Yes, it would go in the highest spot. As you go to the right, as you go down, as you go number, look at the periodic table. One proton, two proton, three proton, four proton. As you go to the right, as you go down the number, as this number gets bigger and bigger and bigger, it gains mass. This is basically organized in an increasing mass. Hydrogen, the lightest. Next goes helium, then lithium, then fluorine. They're numbered by mass. Technically, they're numbered by protons, but in order for it to be stable, you have to add neutrons along with the protons. Every single element, as you go and increase the atomic number, it gets heavier. Because you're adding protons to the neutrons, and the more protons you have, the more neutrons you have to make it stable. There's not a single element that I'm aware of where if you increase the atomic number, meaning you add a proton to it, does it get lighter? So the very last one has to be the heaviest, has to be the lightest. So the chemical makeup of the alien planet's oceans seem to be about the same as Earth's oceans. When the sea water is distilled, the liquid that boiled off and then condensed has been shown to be consisting of molecules of PF and one atom of Nuti. So two atoms of PF. So remember, water is H2O. On this alien planet, they call it PF2 and U. So what element is in U? Oxygen. Where does oxygen go on the periodic table? Goes next to fluorine. It's the topmost element in the group 6A. Then it says there was a solid left behind after the distillation that mostly consisted of a crystal that is composed of Bayou and Krat. What is this crystal? What element is, what chemical is the crystal? There's no reading in this. What is, if you were to distill the Earth's ocean, what is the main crystal that would be left behind? Salt. And what's the chemical formula for salt? NaCl. Na is a group on 1A, and Cl is in the 7A group. So sodium is going to be on the 1A. It's going to be an alkali metal. And if you read up here on alkali metals, we see Bayou is an alkali metal. So this right here should be your sodium. And Krat has to be your chlorine. So Bayou should go where sodium is. Which we could have completed at any time because that's the only one left to go there. And then Krat has to go under fluorine. Because it corresponds to chlorine. And it goes under fluorine. The element called dogon has 4 protons. So the element called dogon has 4 protons. So what element has 4 protons? Beryllium. So it's going to be next to lithium. So count the squares. 1, 2, 3, 4. So this has to be doggone. It's just D, I think. Alright. Floxite is a black crystal and has 4 electrons in its outermost shell. What does it mean to have 4 electrons in its outermost energy level? It means it's in the 4A group. 4A group has 4 valence electrons. Both Rotrap and Doadder have atoms in 4 energy levels. So what does it mean when it says it has atoms in 4 energy levels? It means it's in group 4. Not group 4. It means it has period 4. So recall, everything in this entire row has 4 energy levels. And it says that Rotrap is less metallic than Dodir. We know that as we go to the left, we get more metallic. So since R is less metallic, it means it's to the right of Dodir. But we don't know exactly where it's at. So this information has to be done later. I'm not taking that one up. I'm passing out another one similar to this. Alright, so it says these 3 are all members of group 15 or 5A. Goldie has fewer total electrons than this. So we know that Goldie is going to be above M. So let's look at group 15. Group 15 only has 2 spots, so we can go ahead and put G and M. Again, the atomic number references the total number of protons and total number of electrons in a neutral atom. So if Goldie has less, it'll be above Magnificon, or wherever you say it, on the periodic table. Up, Oz, and Nutai all gain 2 electrons. What does it mean by all gain 2 electrons? What group all gain 2 electrons when it becomes B6A? Nutai is diatomic. Oz has a lower atomic number than Up. So if we look at 6A, there's only 2 spots they can go. And Up and Oz should be above. So it should go Oz and then Up. The element Anaton loses 3 electrons. So when you lose 3 electrons, which group loses 3 electrons? 3A. So let's look at our 3A. 3A, there's 2 spots, so not helpful. The element Zapper and Pi both have oxidation numbers of -2. This is wrong. It's an error. This should be plus 2. So remember how I said that there was a difference between plus 2 and 2 plus? It has to do, one of them is a charge and one of them is an oxidation number. It's irrelevant. I don't really concern myself with it, but oxidation number just means charge. Even though this was a mistake, you could have ignored this mistake and still solved it using the rest of the information. Pi loses them from the 5th energy level, so it has to be something that's in the 5th row. And 5th row in 2A, so this has to be your pi. which is pi, because in this group has a +2 charge, um, which leaves Z. It says Zapper loses them in the third, so Zapper has to be in the third period. And let's see which ones we're missing. So number 8, it says Do. They're in the fourth period. So fourth period is R and Do, and it says R is less metallic, so it's to the right. So R should go here and Do there. And we're looking for something in 3A. So that'd be Anaton is 3A. So AN should go here. Now we're looking for something in 4A, which will be Floxit. That makes sense. And this should have been very easy. It's just puzzle solving to figure it out. Here's another puzzle for you guys to work on. And also periodic trends. Have y'all finished those? Y'all made any progress on them? Which one are you? Yeah, I guess 60. Just a 60 because of you still haven't turned in that one homework. I did. And but it's mostly the 0 for the homework that's bringing you down. It did change your grade. I don't remember. But